How to configure multi-pump function with ATV600. Hello! Today we will show you how to program and use a function which can manage a group of pumps and start or stop those depending on system needs with maintenance phase balancing time. The goal is to demonstrate the embedded features of Ultivar process ATV600. For a pumping system, the feature is called booster. The same function is available also for tank level control. This topic is showcasing the booster feature for a pumping system. Several functions within this feature may be programmed via the graphic display terminal or SoMove software. The embedded web server does not give access to all settings of the booster system, but can be used to monitor the booster features. In this example, we will use SoMove software. There are three different multi-pump architectures. 1. One master ATV600 and several direct motor starting or electronic starters. 2. One master ATV600 and several other ATV600 drives in slave mode. For this configuration, if the master stops, the system stops. 3. Several ATV600 drives that can act as master, master or slave only through multi-drive link technology. If the current master stops or is in maintenance mode, the other master or masters takes over control of the system. The link between the master or masters and slave or slaves is established with an Ethernet option module VW3A3721 to use multi-drive link on each drive. The exchange through multi-drive link becomes active after configuration of communication data on all drives, as well as settings on master and slave side. The maximum capability of the system is 6 pumps. For the three architectures, one or more drives can operate simultaneously to meet the control demand. This video is showing how to configure the third one. Each drive, master or slave, may be programmed on its own PID and sleep wake-up function and tested independently of the booster feature. Each drive has its own feedback of pressure or flow. The Ultivar process can manage both values. The other functions of the drive are set to the default values and may be adapted to the user needs. Here is the hardware diagram of our test bench. The link between VW3A3721 is dedicated to the multi-drive link for data exchange in high-level priority. If you need to monitor the drives, connect the supervision system on the embedded Ethernet connector on Ultivar process. With SoMove software, the booster function is synthesized in 2 tabs. Here is how to set the first master of the booster system in the Architecture tab. MPSA is set to multiple drives with master redundancy. MPDT is set to master or slave. The automatic commutation is decided by the system. MPGN, number of multi-pump devices, is set to 3 for this example. MGID, multi-pump device ID selection, is set to 1 for the first pump. This ID is the address of the pump in the booster function. It is different from the IP address on the communication bus that can be set separately if supervision communication is used. MPME, multi-pump input enable assignment, can be set to DIX if needed. It may be used to activate a drive as a master. This input may be lost if maintenance phase is active on the motor. If not assigned, by default, DI1 is the run command of the drive in the booster system. MPPD, multi-pump master activation delay, is set to 30 seconds. It delays the activation of the drive in the booster system. It may be used to give priority to a drive with multi-master architecture at startup. MPPC, pump cycling mode, is set to pump runtime. Each pump is running in a defined time if all masters and slaves are enabled. MPCP, pump auto cycling, is set to 0.1 hours for this example. This is the running time for each pump. The maximum is 24 hours. Here is how to set the first master of the booster system in the Control Settings tab. BCM, Booster Control, enables the booster function. TOCT, Type of control, pressure or flow. Pressure for this example. It determines the control type and unit, settings of set point. MPST, Multipump Mode Selection, is set to Distributed Multipump Speed Control Mode. The pumps are managed by the speed of the motor. BCPN, Booster Number of Pumps, is set to 3 for this example. If the system requirement is to have only one pump running at a time, set BCPN to 1. One of 3 pumps works, the other 2 are waiting for redundancy. Here is how to set the second master of the booster system in the Architecture tab. MGID, Multi-Pump Device ID selection, is set to 2 for the second pump and so on for the other masters or slaves. The other parameters are set to the same value as for the first pump. In Run mode of the booster system and in the Display tab for booster function, you can access a dashboard to supervise all the pumps of the system if you are connected with SoMove or the web server on any drive of the system. In the bottom of the dashboard, you can check the state of each pump of the booster system. The set point for pressure or flow is set in the PID reference menu, depending on the PID configuration. If PID reference is internal, the set point is set by RPI. Add RPI in the Settings Drive menu in the My Dashboard tab. Verify error warning handling configuration of each drive to avoid unexpected stops on errors or LED warnings flashing. Example for A12 PID feedback in 420 mA configuration and error management if an error is detected. If you want the system to start automatically after power on, isolated systems, you must set the TCT parameter to level. We start the bench and open the motorized valve to 40%. One motor is starting. We open the motorized valve to 60%. The second motor is starting. And then the third one in order to maintain the pressure. If the master detects an error, another drive will replace it as a master. Thanks to the redundancy, we keep the service continuity. Need help with SoMove? Press F1 on any given item to open the contextual help or the product programming manual. Thank you for watching. For more information, please visit our website.